Have you ever just stopped and stared at that little blue dot on your phone's map? I mean, really thought about it? It's this piece of everyday magic we all just completely take for granted. Well, today, we're going to pull back the curtain and see how it actually works. Let's get into it.
I mean, seriously, this little slab of glass and metal in your pocket can pinpoint its own location anywhere on Earth, often down to just a few feet. So how in the world does it pull that off? It's not actually magic, but honestly, the science behind it is just as mind-blowing.
So here's the game plan. In the next few minutes, we're going to see how that little blue dot comes to life, figure out how your phone is literally listening to signals from space, meet the whole global family of systems that makes it happen, and finally, see just how deep this technology runs in our world.
All right, so the best way to understand this isn't with a ton of complex physics equations. No, it's with a simple story. And it all starts with this incredible network of satellites zipping around high above our heads.
Okay, picture this. The sky above you is filled with about 30 incredibly bright lanterns. These are our satellites, and all day, every day, each one is basically shouting out just two simple things. Here's my exact position, and here's the super-duper precise time. That's it, just a constant stream of that data raining down on all of us, ready for anything that knows how to listen.
And this right here is the first key thing you gotta get, and it's a common misconception. Your phone never, ever sends a signal up to a satellite. It's a completely one-way street. Your phone is passive. It's like a radio receiver, not a walkie-talkie. It's just quietly listening for those shouts from the sky.
So, if your phone is only listening, how does it turn those signals into your exact location? Well, this is where some really clever but surprisingly simple high school geometry comes into play.
It's really just a four-step dance. First, your phone listens for a satellite signal. Second, it calculates how far away that satellite is just by seeing how long the signal took to get there. Third, it does that same thing for at least two more satellites to find the one spot where all those distances intersect. And finally, it grabs a fourth signal just to make sure its own clock is perfectly synced up. Let's see what that actually looks like.
So when your phone locks onto that first satellite, it calculates its distance. Let's say it figures out it's 20,000 kilometers away. Well, that doesn't tell you where you are, but it does tell you that you're somewhere on the surface of a giant invisible sphere with that satellite sitting right at the center. Okay, then your phone listens to a second satellite. Now you have two of these massive spheres. And what do you get where two spheres intersect? A perfect circle. So we've already narrowed it down from being anywhere on a huge sphere to being somewhere along a single circle. We're getting closer.
And now for the third satellite. You bring in a third sphere, and it intersects that circle at only two possible points. Now, one of those points is usually flying through deep space at thousands of miles an hour, or it's deep inside the Earth. Your phone's smart enough to know that's probably not you, so it discards the impossible option, and bam! What's left is you. That's the blue dot.
But hang on a second. If three satellites are all you need to find your location, why does your phone always say it needs a signal from a fourth one? This is where the real genius of the entire system comes in.
The whole system, the whole thing, depends on measuring the signal's travel time with insane precision. The satellites have atomic clocks on board that are accurate to within a billionth of a second. Your phone, on the other hand, has a cheap little quartz clock. Even a tiny, tiny error in your phone's clock can throw your location off by miles. That fourth satellite isn't for location, it's for time. It's a perfect reference signal that lets your phone correct its own clock, get the timing just right, and nail those distance calculations.
Now, we've been saying GPS this whole time, but that's actually a brand name. You know, like calling all tissues Kleenex or all bandages Band-Aids. The technology itself is part of a much bigger, more global story.
The system we call GPS is officially the Global Positioning System, and it's owned and operated by the United States Space Force. For a long time, it was the only game in town. But the generic term for this type of technology is GNSS, which stands for Global Navigation Satellite System.
As you can imagine, other countries weren't super thrilled about relying on a system controlled by a single nation's military, so they built their own. Russia has GLONASS, the European Union has Galileo, and China has Beidou, and there are even regional systems from Japan and India. But here's the best part. Your modern smartphone is multilingual. It can listen to all of them, all at once. And that's a big reason why your location is so much more accurate today than it was a decade ago. It's simple. More satellites means more accuracy.
This global network of satellites does a whole lot more than just power our driving directions. It's become this silent, invisible utility that props up our entire modern world.
Of course, it's not perfect. We've all been there, right? You're in a big city, staring at your phone while your blue dot jumps around like it's had way too much coffee. That's because the system needs a clear line of sight to the sky. Tall buildings block the signals, and the signals that do get through can bounce off walls, creating echoes that confuse your phone. It's called the urban canyon effect, and it's why your phone struggles so much indoors or between skyscrapers.
But hey, those minor frustrations are nothing compared to what this system truly enables. It's not just for getting an Uber or finding a restaurant. That precise timing signal is used to timestamp every financial transaction. It synchronizes our cell network so our phone calls actually connect. It guides airplanes, ships, and even self-driving tractors. It helps 911 find you in an emergency. And yeah, it tracks your morning run. It is, quite literally, everywhere.
So that's how it works. A beautiful, elegant system of orbiting clocks, simple geometry, and global cooperation that has quietly become one of the most important inventions of our lifetime. It really makes you wonder, what's the next piece of invisible magic we're using today that decades from now we'll find we simply can't live without?